हेलो दोस्तों, वेलकम टू सनराइज क्लासेस। आज हम इस वीडियो में आपके लिए लेकर आए हैं कुछ सेलेक्टेड एमसीक्यू दैट इज फ्रॉम एड्रेसिंग मोड्स। जैसा कि आपको पता है, हमने इस चैनल पर कुछ क्लासेस कवर किए थे एड्रेसिंग मोड से रिलेटेड। अगर आपने उस क्लासेस को अटेंड नहीं किया है, उस वीडियो को आपने अगर नहीं देखा है, तो भी कोई बात नहीं, क्योंकि हम इस एमसीक्यू के थ्रू हम उन सारे एड्रेसिंग मोड्स को कवर करने की कोशिश करेंगे। We are going to discuss only around 15-16 questions and I think it is enough to understand addressing modes. एक और रिक्वेस्ट करना चाहता हूं मैं आपसे, ये सेशंस बहुत ही इंटरेस्टिंग होने वाला है क्योंकि हर एक क्वेश्चंस के पीछे कुछ ना कुछ कॉन्सेप्ट छुपा हुआ है। तो इसीलिए आप इस वीडियो को तो डेफिनेटली वॉच कीजिए और बहुत ही केयरफुली। अगर आपको समझ में नहीं आए तो आप जो मेन वीडियोस हैं, जो डिटेल्स डिस्कशन है एड्रेसिंग मोड्स का, तब आप वहां उसको रेफर कर सकते हैं। ओके, तो मैं इस क्वेश्चन को डिस्कस करने से पहले आपसे रिक्वेस्ट करना चाहूंगा कि अगर आपने अभी तक इस चैनल को सब्सक्राइब नहीं किया है तो प्लीज सब्सक्राइब एंड शेयर विथ योर फ्रेंड्स। इससे हमारा थोड़ा मनोबल बढ़ता है, इसीलिए आपसे हम्बल रिक्वेस्ट है कि प्लीज सब्सक्राइब। ओके, सो लेट्स स्टार्ट विद द क्वेश्चंस। तो यहाँ पहला क्वेश्चन है, द इंस्ट्रक्शंस ऐड हैज 45, R1 डज। तो सबसे पहले हम इंस्ट्रक्शन को देखेंगे, तो हमें इस इंस्ट्रक्शन को देखकर समझ में आ रहा है कि ये जब भी हम इस सिंबल का यूज करते हैं, हैज का यूज करते हैं, तो दैट इज इमीडिएट एड्रेसिंग। ओके, तो इमीडिएट एड्रेसिंग में क्या होता है, एंड R1 इज रजिस्टर। सो इमीडिएट एड्रेसिंग में क्या होता है, वी आर यूजिंग एज ए कांस्टेंट। तो हम इस कांस्टेंट को यूज करते हैं। तो अगर हम कोई कांस्टेंट को यूज करते हैं तो कांस्टेंट में हम कभी डेटा को स्टोर नहीं कर सकते। जनरली जब भी कोई इंस्ट्रक्शन ऐसे हो, फॉर एग्जांपल ऐड R1, R2, तो हमारा जो इंस्ट्रक्शन का प्रोसेस होता है इस डायरेक्शन में होता है, एंड इट विल बी द सोर्स and this will be the destination. But in the case of immediate addressing कभी भी destination नहीं हो सकता है, it will be always source. तो हम इसका मतलब क्या हुआ कि हम R1 में, now here R1 will be our destination, so R1 equal to R1 plus has 45. Now let's see what are the options is given. The first option is saying add the value of 45 to the address of R1 and store 45 in that address. No. So हम 45 in that address. Here R1 is not, it's not an address. R1 is register, and register directly having some value. It's a direct register addressing. Add 45 to the value of R1 and store it into the R1. This is correct. So this is important. What is the difference between A and B? A is saying that R1 having address, but that's not correct. R1 is, if the R1 having address, then it will be either this one is written, or if it's a pointer, then R1 will be like this, it will be written, or at the rate R1. There are three options, but this is simply written as R1. It means that it is a direct register, so it means the value from R1 we have to read. So the options B is correct. Add 45 to the value of R1 and store it in R1. I hope it is clear. The C is saying find the memory locations 45 and add that content to that of R1. No, that's not correct, because this is not a location. 45 is the constant. None of the mentioned. No. So options B is correct here. Let's talk to the question number 2. In the case of zero address instructions, methods, the operands are stored in. Now, we already discussed the zero address instructions, two address instructions, three address instructions. For example, add. So this is the opcode. It is opcode. Now, here this is the operand. Now, it could be one operand, it could be two operand, and it could possible that there is three operand. So, zero address instructions means there is no operand. So, only opcode is there. Then the question is saying in this case of zero address instructions method, the operands are stored in. Now, where the operand is stored? So, this is this type of like pop. So, for example, pop instruction. In pop instructions, we are not giving anything after that because it is clearly says that we have to read the top elements from the stack. So if it's a stack, then we have to read the top element from the stack. So this is the right option, push down stack. Accumulator is not the right answer because operand is not stored in the accumulator. Accumulator is used to store intermediate results. So here right answer should be the push down stack. That's why zero address instruction. Zero address instruction means one more thing I will explain you here, that is called the implied addressing. Why? Because in this there is no operand. So value of operand is implicitly given in the instructions. That is the part of opcode. So that's why it is called the implied addressing. And implied addressing, the intermediate value, it is going to the accumulator, but the operands are stored in push down stack. So option C is the correct. That's why this zero address instruction is also called the stack operations. Now let's talk about the question number 3. It is saying add has 45. Now this is very interesting. Add has 45. I'm not sure comma is also part of that instruction or not. Here comma is given. Okay, so what it is saying, add has 45 comma, when this instructions is executed the following happen. So we know that has 45, it means that it is saying immediate addressing, and 45 is a constant. So what it is saying, the processors raise an error, the processor raise an error and request for the one more operand. No, that's not correct. The value stored in the memory location 45 is retrieved and one more operand is requested. The value 45 gets added to the value on the stack and it is pushed on the stack. It's not pushed because here we have using the instruction add, so it's not pushed. None of the mentions. So here right answer should be B. The value of a stored memory location 45 is retrieved, but I am little bit confused why it is saying locations 45. It's not location, it's a value of 45. Okay, is retrieved and one more operand is requested. One more operand is requested, maybe because of this comma it is saying one more operand is requested. But if add 45 is there, it should simply, it will be like AC equal to AC plus 45. So it will add into accumulator the 45. So this is my understanding, but here right answer is given B, and the reason for that, maybe this comma is here, so they are looking for the next operand, waiting for the next operand. Okay, Let's move to the next questions. The addressing mode which make use of indirection pointers. So pointers, once the pointers comes, simply it is indirect. If you see my here also, I simply say indirect addressing mode means a pointer. So any indirect mode or pointer both are same. So once you pass the, okay, I will give you the example. So if its instruction is there, add bracket 1005 for example, comma something is there. So what will happen? 1005, this will be the, this is the RAM. So there will be some places 1005, that is the address. So if we are giving the symbol, it means, if we are using this symbol bracket, it means it's an indirect. So what will happen? 1005, it will go, it will fetch the data. That data is as a actually address, or you can say the effective address. So using that effective address, if it's written for example 2005, so it will go to the another block here, that is 2005, and then it will read the data from here, and this is the final data on which operation has to perform. So this is the indirect addressing mode. You see here, indirect addressing mode, we have to visit memory 2 times. This could be possible that the first value is from register, so this part will be from register and this part will be the memory. So we can also add bracket R1 comma something. So this is means here first it will go to the register, they will read the data from the register, and that is the actually effective address from the memory. And using that effective address, they will find the data. So here again 2 times, one it is going to the register and second time it is going to the RAM. So this is also indirect addressing mode, but both the cases is using the pointers. So for that there is a symbol like this one and at the rate this one. So here it will be the pointer, so it will, the right answer will be the indirect addressing mode. Now let's talk about the fifth questions. What is this? In the following index addressing mode, instructions. Now what is the instructions? Move 5R1 comma LOC. The effective address. So we know the effective address. Effective address is the address in memory where final data will be there. Final data on which we have to perform the instruction. Okay, so effective address is the final address from where we have to get the data. So now they are saying in this 5 bracket R1, what should be the effective address? So we can see here they are using bracket like this. So it is like a indirect addressing mode. So indirect addressing mode means whatever the value is there in R1, whatever the value is there in R1, that will become the effective address. Plus, now 5 is given here, so we have to add 5 here. So first we have to go to this address, then we have to jump to the next 5 instruction, 5 addressing, we have to add 5, and then this will become the effective address. I hope it is clear. So answer is D. 5 plus R1 is not the correct one, because here R1 is, it seems like the R1 is saying the value of R1 we are going to add, but that is not the correct. The value of R1 is actually address. Okay, so we have to add 5 in that address. So what it means, the difference I will tell you. So R1 having some value, okay, for example 1024. Now what will happen if I will say R1 then 1024, but if I will say bracket of R1, what it means, they will go to the memory, and that is the address is 1024, and whatever data it is here, that is the value. So here R1 is 1024 is a memory address on which we have to read the data. So that is the meaning of bracket of R1. Simply R1 means the value is 1024. So we are not going to add 5 in the 1024. We have to add 5 in whatever the data is written on the R1. So if R1 has written 2005, then it will be 2005 plus 5. This is called the base register, like based addressing mode. Okay, let's talk about the next questions. The addressing mode which use the PC instead of a general purpose register. PC is good questions. When we use auto increment or auto decrement, which of the following are true? In both, the address is used to retrieve the operand and then the address gets altered. No, in both the cases, it's not true. In auto decrement, first we alter the address and then we going to process on the address. But in auto increment, the operand is retrieved first and then the address is altered. So this is correct, but it is not, the same is not in the auto decrement. Both of them can be used on general purpose register as well as memory location. So that is also correct. So 2 and 3, so answer is D. If you see here, yeah, you see here register indirect mode, we are so here in video I already discussed that for immediate addressing, the hash 35 will be always a source. Yeah, here I also already mentioned, after accessing the operand, the content of this register are automatically incremented. This is for increment, but for the decrement, before accessing the operand, the content of these registers are automatically decrement. So both are having some different. Here first fetch and then increment, but here first decrement and then increment. So for relative, we already discussed the program counter, how they are adding the offsets here 05. This is the based index addressing. Okay. If you want to share this PDF, I can share it, but just put into the comments. Okay, let's talk about the next questions. That is the question number 8. The addressing mode where you directly specify the operand value. So it will be confusing if you see here directly, maybe you can hit the direct, but no, directly operand is there, it means the immediate. it means it's an immediate addressing mode, and this is the like here 45. So this is actually we are using constant. The value of this will not change throughout the program, so for that we are using the immediate addressing mode. Okay, next question, question number 9. The effective address of the following instructions is. So now here again they are asking the effective address. MUL5 R1 comma R2. So what it means, this we have to find the effective address of this one, what it means. So we know that again this is they are using, it means it's an indirect. So what we have to do, we already know that if 5 bracket R1, it means the 5 plus R1. Now what it is saying, R1 comma R2 is there, so it means that R1 plus R2. So we have to read the data from address given in R1. So R1 will give you the data, that is R1 will give you the value, that is the address, and from that address we have to read the data. Similarly here, data from the address given in R2, both the addresses we have to add, and we have to add 5 also as a offset, and then we have to find the exact value, that is the called the effective address. This is again it's a based instructions, so the value will be C will be the right answer. So next question is the addressing modes following which addressing mode is most suitable to change the normal sequence of execution of instructions. Okay, so now it is going to change the sequence of execution. So what is happening, for example, this is the set of instructions, it will be here. Now they are asking change the instruction. So what will happen, from here it will jump to here, or from here it will jump to the another block. It is in the same block and it is on the in the another block. So inter segment and intra segment. So there is two things. Okay, so now what it is saying, address mode is most suitable to change the normal sequence of execution. What is the normal sequence? Normal sequence means if they will execute one instructions, then the next instruction, next and next. That is called the sequential manner executions of the instructions. So to change this one, we have to use the relative one, we have to use the base index, both. So but here only relative is given, so we are using the relative. So this is intra segment. It is preferred intra segment. It means that within one segment, if the instruction is having jump and all, so we are using that. And what is that? The PC plus the offset. So if it's written like, if it's written jump 5, it has to jump 5 more instructions. So first we will go to the PC value and then we will add the 5. Here one interesting thing, for example, currently PC value is just example 100, and at the time of 100, when the PC value is 100, when the PC value is 100 and then he found the instruction is jump 5, but as soon as they are processing the instruction, before that program counter is already increased to 100 to 100, it is not 101. It depends upon how many bits are there for instructions. For example, 2 bits are there for the instructions, then it will be the 102. Next one will be the 104, because 2 bits were used for instructions. So like that, if the 2 bits instruction is there, so it will be next will be the program counter value will be the 102, but we have to jump 5. So the final value will be 102 plus 5, that will be the 107. Actually 5 is again, make it 6. So make it 6 here. So it will be 108. Okay, so next instruction will be 108. So you understand how we are calculating? We have to know what is the size of instructions, then the PC will automatically increase to the next instructions. So if the size of instruction in this example is 2 bits, that's why 100 will increase to 102. Now the program counter is at the 102 and it has to jump 6. So it will be added 6 into the 102, that will become the 108 address. This is the address. I hope it is clear. If you like it is meaningful or it is giving you any benefits, just subscribe and share with your friends. Thank you. So next question is question number 11. Write through technique is used in which memory for updating the data? So this technique is used in cache memory. So right answer will be the D. The next question, cache memory acts between. So where is the cache memory? So cache memory is between CPU and RAM. So cache memory will be between the CPU and RAM. The next question is, the circuit used to store 1 bit of data is called flip-flop. Flip-flop can store only 1 bit of data. So next question is, question number 14 is, von Neumann architecture is. Von Neumann architecture is single instruction, single data. So this is the von Neumann architecture. This is invented in 1945. Before that, what is happening? Before that we have a fixed program. And after von Neumann architectures, it comes to as a stored program. So what is happening in fixed program? Fixed program was the where we cannot change the program. So the instruction is already fixed, and the example of this fixed program is the currently we are using as a calculator. And the stored program is our PC. Okay, the next question is, the addressing modes used in the instructions of add x and y. This is the same questions it was asked in the BPSC TRE 1.0. So what it means, add xy. So there is a discussion about absolute and the index, but it is not an index one, it will be the absolute only. Why I am saying, see, add x comma y. So what is this x? X having some value, y having some value. So it will go to the memory. For example, x value is 1024 and here 1028. So they will go to the memory 1024, find the data. So that is the data 1, and the one is 1028. It will find the data here, that is the data 2, and then they will just add the data 1 and data 2 and store into the x, this address. So this is the absolute or it's a direct, both are same. So it's maybe confused with without direct, it's not there. So absolute and direct addressing both are same. Okay, This is the last questions. Let's talk about this. Register keep track of the instruction stored in the program. Stored in the program stored in memory. Okay. So this is the program counter. Program counter. This is the register that will keep track of the instructions stored in the program, stored in memory. So program, once it is coming into the memory, that will be the instructions. So like this will be the instructions. So the program counter will only keep track of the instructions. So this is the answer.